say, hey, PG2, join me under the cache group name, and put myself in. Self is the process ID of my own process, and I can return in my gen server some state which hangs onto my cache. And so as I am getting new events coming in, I actually get an update cache message that comes into that gen server, and I can actually say, if I'm on the server where that event occurs, I can create the message. I go get all of the members in my group, and I use a list comprehension, and I say, okay, for all the actual members of all the processes that are actually running caches, send them, that exclamation point means send them a message. Send them the message above, which is this tuple, update cache. I pass in my process ID, and I pass in the data I want to change. So I say, for all the processes in my group, send them this message, but don't send them the message if it's myself. So in other words, I can in one line say, send this message to every server, but don't send it to myself so I don't have to worry about infinitely recursing because I'm updating myself over and over. So literally what would be hundreds and hundreds of lines of retry code and logic and thinking through socket connection cases and registries and all the stuff you have to do in Java, or any other language that doesn't have these constructs, is literally one line of code. This is the kind of thing that as you build a bigger system, you want to cry tears of joy because it's one line of code and you can do so much so quickly. So in practice, what does that look like? A heart comes in to an Erlang node. PG2 has the actual process ID on all the other servers. We write that to disk. RDS is like the MySQL database. In this case, at this point, it might go to some other databases too, but it gets written to the database. But it